Today we are going to look at the property for trapezoids. Alright, so we're going to start with a picture of a trapezoid. So the way that we know this shape is a trapezoid is it has one pair of opposite sides parallel. So the top and the bottom in this case are parallel. The sides are not parallel. The sides are going to go intersect each other. So remember, parallel lines never intersect. Parallel lines have the same slope. Alright, so here's the type of problem that we might see with trapezoids. Alright, so similar to yesterday with our parallelograms, you want to know what shape are we dealing with. So we're dealing with trapezoids. And so that means that when you're on your green chart, you're down here on trapezoids, the row goes across, right? And then, don't be sad, but you have to decide, is this problem talking about sides or angles or diagonals? Sides, angles, or diagonals. So look at where your numbers are and type in the chat for me. Are these numbers about sides or angles or diagonals? Oh, such awesome participation. You guys are so great. And you are absolutely right. This problem is about angles. Now, maybe you knew it was about angles because you saw the degree sign. Maybe you knew it was about angles because those numbers are inside the trapezoid. So the angle measurements are always inside the shape. But you are right, those are about angles. So then you want to go on your chart here. And if you have a chart that you can write on, go ahead and take it out. And next year when I make this chart, I'm going to put this title on the side. But up top here, these columns are all about the sides. The middle columns are all about the angles. And then these columns over here are all about the diagonals. So you might want to write that at the top of your chart if you have a physical chart with you. Alright, so we're talking about angles here, and so we go down to trapezoid, angles, and look, there's only one check mark right here, and what does it say up here? Consecutive angles are supplementary, and supplementary means adds up to 180. So we look over here at our trapezoid and we go, oh, yeah, these angles are consecutive. Right? See how they're right next to each other, one right after the other. So these two angles are going to add up to 180. So we're going to write 45 plus x plus 10 equals 180. That's the geometry right there. Knowing the name of your shape, knowing the angles, looking at your chart, knowing that supplementary means adds to 180, and then writing the equation. Once you do all that, the geometry part is done, and now you just need to add in a little bit of algebra, and hopefully you guys are getting better and better at solving your equations. So we want to take everything that's on the left side and we want to combine our like terms, right? So the 45 and the 10, they're going to add together. And so we're going to have x plus 55 equals 180, right? And then we're going to subtract 55 from both sides. So plus 55 minus 55 is 0. Bring down my x. This is where you'll take your calculator. You'll do 180 minus 55 and type in the chat what you get for that answer. 180 minus 55. Alright, awesome participation, guys, and you are correct. X is 125. So let me go in and put some labels on these vertices. Let's call this TRAP, trapezoid. So if it said find X, X is 125, we did find that. Now what if it wanted to find the measure of angle R? What is the measure of angle R going to be? Alright, my goodness, Melanie, they're just giving me answers so fast today. So to get the measure of angle R, you're going to substitute, right? So the measure of angle R is equal to x plus 10. So you're just going to take your 125, plug it in, and you're going to do 125 plus 10, and you're going to get 135 for the measure of angle R. So sometimes on your test, you're going to have a two-part question. It's going to say first find X, then find something else, right? So you find X and then you plug it in. Alright, so now let's do a second trapezoid problem. Alright, so when we look at this picture, okay, these two sides are parallel, but then these two, and we call them the legs, they're congruent to each other. So this is not only a trapezoid, this is an isosceles trapezoid. Alright, so let me take a moment, right, and we're just going to go back in time and remember this little thing that we learned about before. You remember about the isosceles triangle? An isosceles triangle has two congruent sides. So an isosceles triangle looks like this. These two sides are congruent. And what we learned in isosceles triangles is if these two sides are congruent, the angles across from them, called the base angles, are congruent. So if these two sides are congruent, then these two base angles are congruent. Well, here's what's so awesome, the connection. Isosceles triangle, isosceles trapezoid, the same thing happens. If these two sides are congruent, then these two angles are also congruent. The other thing is, when you look at your chart, isosceles trapezoid, base angles are congruent. The base angles are congruent. So these two right here, these are the base angles. So in a trapezoid, this is a base, and this is a base, and this is a leg, and this is a leg, right? So the two leg sides are congruent and the base angles are congruent. So since those are congruent, we would write this equation. X plus 20 equals 2x plus 10. That's the geometry right there. Knowing what your shape is, knowing what the property is, knowing that these two are going to be equal to each other. So just compare. Up here, they added together to 180. In this problem, they're congruent, they're equal. So you're going to write different kinds of equations for different problems. Now, once you write the equation, now you're just going to do algebra. But notice this one has x's on both sides. So when that happens, we want to start by subtracting an x, so that x take away x will make 0. We can bring down our 20. 2x take away x leaves 1x left. And then we're going to subtract 10 from both sides. And x is going to equal 10. Alright, now let me add some labels to the vertices. This S, T, U, V. So x is equal to 10. But then what if they said find the measure of angle S? So all you do is you look on S, measure of angle X is X plus 20, and then this is where you're going to come substitute. This 10 is going to come in place of the X, 10 plus 20, so the measure of angle S is equal to 30 degrees. Alright, is everybody doing okay? Tell me in the chat. Do you understand? You can do yes, no, maybe so, a little bit. If you have a question, type your question. Alright, we got one more example. One more example on our trapezoids. Alright, this is a special thing that's not on our chart or anything. And this is called the trapezoid mid-segment. Alright, so what does this even mean, a mid-segment? So it's a line segment that comes right in the middle of the trapezoid, parallel to the two bases. So right here, from here to here. I call this AB. Line segment AB is the mid-segment. And the mid-segment is the average of these two bases. Right? So AB, the mid-segment, is base 1 plus base 2 divided by 2. It's the average. So it's right in the middle. Alright, so what that means is if I took a ruler and I measured this line segment, and let's say this was 8 inches, I mean, it's obviously not 8 inches, that's too small, but it's not drawn to scale. If that's 8 inches, and down here this is 14 inches, and I wanted to find AB. So I just do 8 plus 14, and then I divide that answer by 2. So I take my calculator, and I do 8 plus 14, enter, and then divide by 2, and I get 11. Or on my calculator, I could do parentheses, 8 plus 14, close your parentheses, divided by 2, and I get 11. But here's what you can't type. You can't type 8 plus 14 divided by 2. If you do that, the calculator's going to do the dividing first. You're going to get the wrong answer, right? So you either have to do 8 plus 14, enter, and then do division, break it into 2 steps, or you put the parentheses. So that means that this right here is 11. Now, here's the way that I like to think about it too. 8 plus 3 gets me to 11. And then 11 plus 3 gets me to 14, right? This is 11. This side is 3 lower. This side is 3 higher. It's equally spaced between those two. It's the average. It's halfway in between. All right, so I know I said one more example, but that's just one more idea. Now we have to do it with what if there's some variables on there. So let's draw another trapezoid that has a mid-segment. This time they're going to tell us the mid-segment is 10. This top is x plus 6, and this bottom is 2x minus 4. Alright, so I'm using this formula right here. I'm going to plug everything in. So AB is 10, and that equals base 1, which is x plus 6, added with base 2, 2x minus 4. The whole thing is divided by 2. So that's how you're going to set it up, right? And if you do the setup, you get half the points right there. That's your geometry. You understand that a mid-segment is base 1 plus base 2 divided by 2. Now we're going to do the algebra. So we've got this fraction here, and we've got this whole thing is divided by 2. So how do you get rid of division? You get rid of division by multiplying. So we're going to take this whole entire side, and we're going to put a times 2, and then on this side we're going to put a times 2. Okay, 2 times 10 is 20. This 2 divides with this 2. 2 divided by 2 is 1. Alright, so now we bring everything else down here. X plus 6 plus 2x minus 4. Alright, now we're going to go combine our like terms. We're going to put the x's with the x's. X plus 2x is 3x. We're going to put the numbers with the numbers. Plus 6 minus 4. So 6 minus 4 is 2. If you're not too good with your negatives, put it in the calculator. Alright, so then we're going to subtract 2. 18 is equal to 3x. And we're going to divide by 3. X is equal to 6.